Hello everyone, welcome to Zelin's class again. And today we are going to talk about binomial expansions. Well, we learned a part of it in AS. So we learned the basic ones, which is the general one, with a plus b bracket to the power of n. And the expansion of it is this equation, and which you should have learned in AS level, which is that. And however, for in this case, our n is always a positive integers, which means that we can't solve the case which n is a fraction or decimals by using this theorem. So we can't do this. So now, this year we are going to learn another formula, which is 1 plus a to the power of n. But here the n is a real number, so which means n can equal something like 0.5 or 2 over 3 or whatever. So and the equation is here, so it's 1 plus an plus n times n minus 1 over 2 to the factorial times a squared and dot dot dot. It is to infinite, so it will never end. So however, now consider this case. So if we have a squared, a cubed, a to the power of 4 into infinite. If a is, so the absolute value of a is greater than 1, so such as a is equal to 2, then our 2 squared is 4, 2 cubed is 8, and then 2 to, for example, a very big number, then it will have a very big number here. So which means that our sum of that is equal to infinite. So you can't really solve the value for this anymore if the absolute value of a is greater than 1. So which means that if we want to apply this formula, we need to have another range for a, which is the absolute value is smaller than a. So that is the extra thing you need to know. And now, do you think that this equation is very complicated? Well, it is complicated, but you can understand it very easily. So I think most of you should all very familiar with this equation. And now let's expand this equation. No, I mean simplify it. So here there are combinations here, and let's change it into algebra forms. So now, for nc1, we will change into n. And for nc2, we will get n times n minus 1 over 2. So which means that, okay, now, for a plus b to the power of n, let's substitute a equals 1. So we will get 1 plus b bracket n. And if n is a positive integer here, so we will have 1 plus nc1b plus nc2b squared plus nc3b cubed and then 2bn. And now, because we know that nc1 is equal to n, so which means here is equal to nb, and here is n times n minus 1 over 2 times b squared plus n times n minus 1 times n minus 2 over 3 factorial b cubed and plus and 2bn. However, if n is a fraction, then we don't have the last term, so it is into infinite. And now let's look at this equation again. It is the same as this equation now. So we can say that the equation that we are learning this year is actually coming from the equation we learned last year. So that is how you memorize this equation. And now let's try some questions. Okay, the first question is very simple, which is just expand this up to the term x cubed. Well, firstly, seeing this, we should try to change it into a form like 1 minus 4x to the power of a, right? And we know that square root is actually to the power of a half. So we can just simply write 1 minus 4x to the power of a half. And now let's use our theorem, which we have 1 here, then plus, well, a half times bracket negative 4x, then plus a half times a half minus 1 over 2 times negative 4x squared plus a half times a half minus 1 times a half minus 1 minus 1 over 3 factorial times negative 4x to the power of 3. And let's simplify this, which is y minus 1 minus 2x plus, well, this is negative half, negative a quarter, and then so negative an eighth times 16x squared, and then plus, so 6 here, and half, negative half, and negative 3 over 2 times negative 64x cubed. And we will have 1 minus 2x minus 2x squared, and here is negative, oh well, positive 3 over 8 times 1 over 6 times negative 64x cubed equals 1 minus 2x minus 2x squared plus, well, so here is 16, 1 over 16 times negative 64x cubed, which is equal to 1 minus 2x squared minus 4x cubed. And that is our answer. Yeah, so that is this question. And now let's try a harder one, which is in the expansion of 1 plus ax to the power of n, the coefficient is negative 6 and 27 for x and x squared. And let's find a and n. So what does this mean? Well, it just means that we have a negative 6x inside, and also we have a 27x squared inside. So this is the two things that we should know. And now, because of this, we should use that to find a and n. So now let's expand this first, which is 1 plus ax to the power of n. Let's expand that. It becomes 1 plus nax plus n times n minus 1 over 2 times ax bracket squared. Only for x and x squared, which means we only need to do until here, and we don't need to write anything else. So now, because it says x is the coefficient of x is negative 6, so a n is equal to negative 6. And for we have a squared times n minus 1 over 2 is equal to 27. So these are the two simultaneous equations that we need to solve. And now we can see that let's substitute a inside. Well, a is equal, so substitute y, so y into 2, which will have a equals negative 6 over n. And now we have negative 6 over n bracket squared times n squared minus n over 2 equals 27. And we have 36 over n squared times n minus 1 over 2 equals 27. Well, I just see that these two n can cancel out. And here is 18, here is 1. So we will get 18 times n minus 1 over n equals 27. And we have 18, so 18n minus 18 equals 27n. Then we have 9n equals negative 18. N is equal to negative 2. And which means a is equal to 3 because of that. And we solved it. Okay, so that is all for binomial expansions. And I hope you understand that. And if you want some more information, you can go to the channel by Daniel Dallas. And thank you.